the intensity I of light from above varies inversely as the square of the distance. Now I'm going to use I to stand for the intensity. I'm going to use D to stand for distance. And it says the intensity varies inversely as the square of the distance from the bulb. Now I is 90 watts per meter squared when the distance is 5 meters. Find the distance where the intensity is 40 watts per meter. Well, step 1 is to write the model. Now the intensity of the light varies, or the intensity of light from above varies inversely. Now inversely means it's going to be K over something. What's it going to be K over? K over the square of the distance. So the model is going to be that the intensity I is K over D squared. I varies inversely as the square of D. Inversely told me to divide, and of course the square of D is what told me to write D squared. Now step 2, we want to use a given measurement to find K. Well, the given measurement is I is 90 when D is 5. So I'll replace I by 90 and D by 5. So I get 90 is equal to K over 5 squared. So I'm trying to find the constant for this particular bulb. So the particular situation in this case is the particular bulb. If you change bulbs, you're going to change K, but we're not. We're keeping the same bulb. So for this bulb, the intensity would remain constant. The K would remain constant. Well, we know that 5 squared is 25, so to solve K, I simply clear fractions, so I multiply both sides by 25. So I get 90 times 25 is K. Just multiply 90 by 25, multiply this by 25, so I'm left with K. Multiply 90 times 25 to get 2250 is K. So check on your calculator that 90 times 25 is 2,250. Now, go back and answer the question. What is the question? Find the density where the intensity is 40. Well, I'm getting ahead of myself. In step 3, I simply replace K by the value. So I go back to step 1. I have I is equal to, in place of K, I write the value of K for this particular bulb, which is 2250 over D squared. Now I go back to my question, and it says, find the distance where the intensity is 40. So I'm going to put I is 40, and I want to know the D that goes with that. So I get 40 is equal to 2250 over D squared. Now we want to solve for D squared. Well, the first step would be clear fractions. So I need to multiply both numerator and denominator by D squared. And of course here, the D squares will cancel, which leaves me 40D squared is 2250. Divide by 40. Of course, if I divide one side by 40, I divide the other side by 40 to get that D squared is 56 25/100. Now notice here the 40s will reduce. Give me the ones. I'm left with D squared. And take your calculator and do 2250 divided by 40, and you will get 56 25/100. Well, I don't want D squared. I want D. So to get from d squared to d, I need to take the square root of both sides. So, didn't write it exactly right again. So the square root of d squared is the square root of 56.25. Now, normally speaking, when you take the square root of both sides, using the square root theorem, you'd have to put plus or minus. But d stands for distance. You can't have a negative distance, so we'll just use the plus sign. So square root of d squared is d. The square root of 56.25 is 7.5. So the desired distance is 7.5 meters. Again, you need to verify this on your calculator. You need to take your calculator and enter 56 and 25 and take the square root of it, and you will get 7.5 meters. Some of you are thinking, well, I thought you promised a hard one. That was not hard. Well, maybe I can't think of a hard one, but I will give you one that might be just a little more interesting. The volume of wood, V, so V stands for the volume in a log, varies jointly as the length L and the square of the girth. Now I'm using L to denote length, G to denote girth. Now the girth is the distance around the log. So if you've got a log and you're trying to get the distance around it and measure the distance around it, that would be the girth. If the volume is 35 cubic feet when the length is 20 feet and the girth is 5 feet, what is the volume when the girth is 3 feet and the length is 25 feet? The first step is to write the model. So the volume varies jointly. That means we're going to be multiplying the two variables together. It varies jointly as the length and the square of the girth. So the volume is K times L times G squared. K is your constant of proportionality. Now we're going to use the information given to find out what K is. So let's go to the given information. The volume is 35 cubic feet when the length is 20 and the girth is 5. So the volume is 35 when the length is 20 and the girth is 5. So I replace V by 35, L by 20, G by 5. And now we simply solve for K. I get 35 is 500K. Now the way I've got that, 5 times, do the exponents first, so 5 squared is 25, then 25 times 20 is 500. If you don't follow in your head, check on your calculator. If you square 5, all of you agree you get 25. Now multiply 25 times 20. So I get 35 is 500K. To find out what K is, I would need to divide both sides by 500. I have no idea where the 2 came from. So I'll 500K, 35, so I have the 500K divide both sides by 500. 500 goes to 500 one time, 500 goes in 500 one time. So that leaves me with, and do this on the calculator, do 35 divided by 500 on the calculator, and you're going to get 0.07 is equal to K. Step 3 is to go back to your original formula and replace K by what it's equal to.